So in this problem, this is problem 2.9.29, and they ask us if f of x is equal to 4x plus 3, we want to show that the inverse is equal to this right here. Now, if you recall, showing that a function and its inverse are actually that they are inverses, we can do that by verifying a couple of things. So if we verify that the function and the composition of the function with the inverse in this direction is equivalent to x. And then we also have to show that the composition in the other direction is equivalent to x. If we show both of those things as being true, then we can verify that this is indeed the inverse of this function right here. Okay, so I'm going to go ahead and start by showing this. So if we're going to take f and compose it with the inverse, that tells us that we're looking at f of the inverse. And I have written that incorrectly. So what we're doing here is we're taking the inverse and we're plugging it into the function f. So I'm going to take this function, that portion of it, and plug it right in there for the x. Okay, so when I do that, then I'm looking at 4 times x minus 3 over 4, and then plus 3. And if we simplify here, 4's will cancel. We're left with x minus 3 plus 3, which is x. So this one is checked off. We've shown that when we compose f with the inverse in this direction, that we end up with x. What we need to do next is show that the composition in the other direction is also x. So this is going to be, whoops, it's f inverse of f of x. So right now we're showing this one. So this is f inverse of f of x, which in this instance what we would be doing is actually taking f of x as the input and then plugging it right in there for the x. So this would look like 4x plus 3 minus 3 over 4. And then simplifying that, we end up with 4x over 4, which reduces to be x. So this one also checks, and the fact that both of these have been equivalent to x means that we have verified that these actually are indeed inverses.